Hey everybody, we're going to be talking today about just a couple of theorems and properties of triangles, and they're going to have to do with creating triangles that have hinges on certain vertices. So the first case that we're going to talk about is, I don't know if you guys have ever seen a drawbridge before, but here's what an example of a drawbridge looks like. This is a drawbridge that is over a canal in a very populated area, as you can see, probably a marina in the background there. And what the goal of a drawbridge is for large ships to be able to pass through when it's open, and for traffic to be able to go from one side of the waterway to the other when it's closed. Well, even when it's closed, what we want is there to be a little bit of space underneath, so that obviously we don't want the drawbridge right on the surface of the water. And also smaller vessels should be able to pass underneath, like kayaks or other recreational vehicles that aren't maybe quite as small or have such a tall mast. So the purpose of a drawbridge, again, is for it to be closed, but for there to be able to be space underneath so that it can be functional. So what I would like us to think about is that the points on either side of the waterway are endpoints of a side of a triangle. Because when we think about this visual for what kinds of sides can form triangles or not, in the exploration we're going to show here, hopefully that'll help you understand the visual a little bit better. So again, we're going to consider that there is a vertex on either side of the waterway and that the drawbridge pieces themselves are on hinges. Here we have a case where our drawbridge endpoints from either side of the river are too short. They are not spanning the distance of the river itself, so we are not able to close the drawbridge and have traffic flow at all, no matter how much we manipulate those hinges up or down. They're just never going to meet. So that's a problem. So now we're going to try to visualize and see if we can put values to the sides of the hinges and compare that to the width of the river. So here's hinge number 1 on the side, and here's hinge number 2. And I hope what you can see is that when the hinges pieces are the exact same length as the width of the river, we're not going to be able to get a triangle out of it. Which means, going back to our picture, that there's not going to be space for those smaller vessels to go underneath the bridge when it's closed. We need there to be more space underneath. So we know no triangle forms when those endpoints are just touching and the drawbridge folds flat. So we're going to just lengthen, you saw me move the slider there, just by a little bit, that side B, so that we have 4 and 8.5 right now is more than 12. And you can see we are able to form a triangle. So here is our hinge on our triangle, and we are between two sides with a defined length of 5 and 9. And so now we're going to connect those two sides with an imaginary third side, if you will, and we're kind of watching what the values are. If we close that hinge all the way, we're not getting a triangle unless we go just above having a triangle be flat. And then if we open the hinge all the way this way with those two defined sides, 5 and 9, we can see that side 3, if it's 14, we got a problem. If it's a little less than 14, we're okay. So now if we close the hinge all the way, we have sides A and B. What we want to do is subtract to figure out what our minimum side could be. Now if we open our hinge up all the way, not quite flat, what we want to do is add to figure out what the maximum could be. Now realize we're not going to ever be touching the maximum or the minimum, so we want less than signs for both.